everyone, I am Manuel Yedo, CEO of Greatech, and I'm happy to say a few words about our Simulate business. Our flagship product is Advanced Design, an amazing BIM-compliant structural analysis software. It represents around 500 years of research of development, collaboration with thousands of customers, and probably millions of projects.
Hello, everybody. Thank you for joining me for the third day of our Greatech Advanced Design Week set of webinars. Today's webinar topics is easiest way to store analytical data and results in Autodesk Revit with Advanced Design. Let me introduce myself first. My name is Petr Laník, and I'm a local product manager for Greatech Simulate products in Czech Republic and Slovakia, and I have some structural engineering background in last 20 years. At the beginning, I would like to share with you the words of our CEO, Steve Holder.
Good afternoon. Firstly, my name's Steve Holder. I'm the COO of Greatech Group. And on behalf of my colleagues, Julie Bendel, the Vice President of our Simulate Group, Joseph Pace, our Product Director, and all the speakers and staff, I'd like to welcome you to Greatech Advanced Design Week. I'd just like to spend a couple of minutes just talking about Greatech, as I know many of you are new to Greatech, but we are 30 years old. We're headquartered in Bièvre in France. About 15% of our business these days is done in our mother country. We now operate through 11 countries worldwide, throughout 48 offices. We're a healthy, profitable and growing company, which is obviously important these days. We're one of the largest Autodesk partners worldwide, and we're very uniquely positioned in this CAD CAE environment to provide this round trip through our BIM solutions. We've 550 staff, 100 located in our R&D centre in Romania, a lot doing this advanced design solution that you will see this afternoon and throughout the week, and our customer first, millions of projects completed in Greatech software. There's 50,000 plus support cases per year, and obviously we deliver a lot of training around the BIM solutions as well. If you look at our story, we actually split it into 4 different categories. So we have create, we have simulate, we have fabricate and manage. Today we're looking at simulate, which is about using that BIM model to simulate your designs for use in the real world using the market-leading Greatech technologies. Often before that, we've had create, which is about using the Autodesk products, AutoCAD, most notably Revit, and we enhance Revit with our Power Packs. So many of those common tasks that you would use in Revit that might take some hours to do, if you use Greatech Power Packs, you buy your subscriptions from Greatech, you then be able to do those a lot quicker with our Greatech Power Packs. We then take all of that data, the real world data, through to fabrication. It's about delivering finished fabrication product onto site delivery, and we manage all of that work in progress that our customers do every day, whether that's Excel documents, DWGs, PDFs, Revit files. We manage all that and draw IP before collaborating with an external CDE. That might be BIM 360, a site for projects. Doesn't really matter who on that side. So when you look through our create, simulate, fabricate and manage products, you know, we're talking about Autodesk software. It's leveraging that Autodesk AEC collection for BIM design. It's enhancing Revit, particularly with our power packs, whether that's for Revit, Advanced Steel. We also have products on the manufacturing side. You know, we have hundreds of tools that are there for your daily productivity. Today, we're talking about Simulate with Advanced Design, our FEM structural analysis solution, you know, really dedicated to structural engineers who want to operate in a BIM environment. We then have BIM designers, you know, it's a range of apps for the structural process, high degree of design-driven modeling, the documentation, and really around, you know, multiple, whether it's steel, whether it's concrete and rebar, those structurally biased workflows. We then go on to workshop, easy to use, MIS, you know, fabrication management system, and for the rebar side, we have an A+ software that all comes under the workshop brand. So we're about taking conceptual design through detailed design in Revit and BIM designers, through analysis with advanced design and some BIM designers, and we manage all that with our OpenTree products, our work in progress data, managing your IP before we start to collaborate with an external CDE. Hopefully that gives you some flavour of the size of Greytec and the scope of Greytec. Obviously today we've invited you to learn more about advanced design in collaboration with some other products and our BIM workflows, but we also go out to the create side, the fabricate side, and the management of that data. So thank you very much for all attending. I hope you've attended multiple sessions throughout the week, and we look forward to welcoming you if you're a new customer to Greytec, or if you're an existing customer. Many thanks for all of the orders, all of the work that you do with us. It's very, very much appreciated. So I'm going to hand over now. Many thanks.
Well, thanks to Steve Holder for his short introduction into Greytec products and the BIM workflow. Yesterday you could probably, if you join the webinar with my colleague Alessandro Bordin from Italy, it was the basics of the BIM workflow between Revit and Advanced Design, and I will start with a short introduction. The overview, we are starting again in Revit. You see the analytical settings, model itself, and BIM Connect possibilities. Then we swap to Advanced Design, define supports, loading areas, load cases, and loads, load combination, of course, to the analysis. And then we export our model with results back to Revit, synchronize, and use the structural analysis add-in and Power Pack for Revit detailing and design add-ins. So in Revit, we start with some analytical settings, and we check the model and speak about how to load, add support, load cases, maybe in Revit. And the last part of the Revit in this first step will be settings for BIM Connect and one-click export. So we will start our project now as Revit. You can see some administrative building, and first we go into the analytical settings. We need to check the settings for proper export, so some automated auto-detecting differences between the physical and analytical model. As you know, the physical model and analytical model are two models available in Revit. In the same ribbon, you can see that we can add loads, load cases, and load combinations as well. If I open some template file for structural template, you can see that these are already defined there, but it depends on your own template as well. In our case, we try to skip the defining the loading in the Revit and load combination, as we missing the load combination generator and climatic loads generator. We check the supports. It's possible to add them in Revit as well, called here boundary conditions. But as you see, we get some footings and continuous foundation beams that are automatically exported into our structural software advanced design, so no need of this. And the only possible support would be planar support, but I would say it's much easier to do it in advanced design. Next, we check our settings for BIM Connect. For the export or import loads, so we don't need to export or import loads. We can set for exporting, maybe exporting with the only analytical model, but it's not necessary right now. The most important is setting the concrete section mappings with the proper families used in Revit. And I said in the beginning, we won't add any load, but we put the load case for the self-weight. Then we can export into advanced design. You can see the self-weight load case selected and automatic launching of the software after, or we just press the advanced design button and do the export automatically. So now we get the model open in advanced design. I'll be just short click, and I'll just talk about what we do in advanced design right now. We define the supports, the planar supports if necessary, because the rest is automatic. We define the loading areas. They serve for planar load distribution and for climatic load generation. We have load cases and loads, especially on the slabs. And we defined load combinations by generators and do the analysis. So now you can see the model, the supports, the footings are transferred into point supports, and the continuous footings into linear supports. On the left hand side, you can see a project browser where we can easily manipulate with the project, switch on or switch off the systems, the floors or the subsystems. And as well, we can define the loading here. You can see the dead load was already, the load case for the dead load was imported from Revit. And we can use the project browser for creating load case families. Load case already defined, so we just add live load, snow load, and wind load at the beginning. The self-weight is assigned automatically to elements. It could be changed as well. The live load has some, the load case has some values, some settings, and we can choose, for example, the slabs for the live load and apply the live load on the selected slabs, the value and the direction of the loading, and it's applied. I'll skip here a bit. I apply some other loading, more difficult ones by shape to the other floors. And what we need now, it's the load areas. The load area can be defined directly on the slab, or can be defined by clicking the points. The service of the area, load area is, there is two purposes. One is to distribute the load from the load area to elements that are under or in the same plane as the load area. And the second is the generation of climatic loads automatically. You can see the load area has some some properties in the property window, the span direction, whether the load is distributed in Y and X direction on both. It can serve as rigid diaphragm as well, and setting whether it will distribute the load from snow and wind, generate them. Can, for example, set the snow accumulation, and the wind. We can define the coefficients based. The standard are based on the used standard. Now, as long as we have the load areas defined, we can see they're assigned into the special systems, so we can easily operate with them, select them, and as we have them, we can use the automatic generator for climatic loads, snow and wind. Just at the moment delete the loads we had there. The load case is prepared without any loads, and you can see the settings for the snow loading, typical value, the snow load based on the typical value. Same for wind, setting the wind speed region. You can use, I'm using the Czech standard, so the map of the Czech Republic, and get the values automatically set according to wind speed region. As soon as this is done, we can create automatically the climatic loads. Okay, once more, automatic generation of loads for snow and wind. I can, measure moment, can see for example, the snow drift loads automatically generated in one direction and X and Y direction, and similar the distribution, automatic distribution of the wind loads based on the used codes in one direction. For purposes of not having such a big file and not so long calculation, just for this model, we just use one snow load and one wind load. We can easily renumber the wind load case, so it's number 4 right now. And what we are needing next is the combinations. You can see I already defined some of them, so we will delete the already defined one and create new ones. You can use 2 different generators. The simple one based on a Eurocode, or the detailed one that is a matrix based generator with the dependencies of each load case and setting some rules, exclusion and forced load cases and load families. The other possibility now is to export or to import the load cases from Excel sheet. It's not the only loads we can define. We can also define several different ones, type of loads, for example, seismic loads and temporal dynamic loads. As soon as we define them, then automatically the model analysis is prepared, and with the 2 possible methods for defining the modes, either using eigenvectors or load-dependent risk vectors. And the modes can be targeted by either by a number of modes or in the load-dependent risk vectors by participation ratio. Of course, the earthquake family or seismic family, and dynamic temporal load family has their own values and settings. You can, for example, set the harmonic solicitation type. But as this is not exactly the point of the presentation today, just to show you the possibilities there. And the next step is to apply the properties, the design properties for the reinforced concrete elements. There are properties either set in properties, or if you use the template, for example, for columns, then the properties are set in the template table. You can set the cover of the reinforcement. We can set if you want to calculate cracking or not. We can set defining the column or beam calculation, buckling lengths, and so on. Similar setting for the slabs. Again, you can see used general design template slab. Go to design template, and for the slab, again, setting for the finite element calculation, the general one, and then the design properties for slab. Here we don't select the automatic correction of reinforcement for cracking. You can set the punching shear. And for the top slab, you see that the values are available, the FEM values are available in properties, and design values, design conditions as well, as we don't use the template in this case. And here we set the correction of the reinforcement according to cracking. Same for the other slabs. We don't set the design calculation, so on the other elements we only calculate the FEM results. Before we do the design calculation, we have to set the settings, type of calculation method, coefficients, either if you use a creep and shrinkage in the calculation, and calculation sequences, defining the detailed reinforcement, punching, and so on. As soon as we are done, we can start the calculation itself. Should run without any problems. We don't have such a big model. And now we can display the results, either FEM results, forces, for example, select the columns at the bottom and display the moments around y-axis. Similar for slabs, we can, for example, display the deflection, the elastic deflection of the selected slab. Okay, select the slab and we can display the elastic deflection. The next one, you can see the elastic deflection of the top slab from FEM results, and the other set of the results are the design results. Here we can find, for example, total deflection with the cracked section of the concrete. We can compare the results and the deflection, the elastic deflection, and the total cracked concrete slab deflection. There are several ways, of course, to display the values. You can use, for example, ISO lines, and we can save the views to use them further in our analyzing process in the post-processor. You can switch between the views, and they are saved, so they are useful for next work. Before we continue, we have to set the options for export of linear elements and export of theoretical reinforcement in application options. Then go to the BIM window, import button, and export to the GTCX file. And we are back to Revit. What we'll do, we'll synchronize back to Revit with the results, and we'll look at the structure analysis add-in from Autodesk and our PowerPack design and detailing add-in in Revit. So first, we have to synchronize the results. For synchronization, we choose import FEM results for combinations and provide the synchronization, same as you could see probably yesterday. Select the proper file, and in this case, select all the changes, accept them, and apply them. In this way, we will load not only the model, but also the results. Just one short reminder, if we export from the project window in Advanced Design, you only export the geometry, not the loading. Okay, we are back into Revit, and we can see that in Result Manager, we can see all the results. Let's choose the ones for linear elements. And let's, for example, display moments around Y. For the columns, you can play with the settings of the view. You can see the results are only one set. So if we want to display the results, for example, only on the bottom floor, we just have to hide or set the view for such a structure. Then the display will be only for this part, moments in Y and Z. Of course, we can choose any of the imported combinations, apply the elements for the elements, moments, same forces, just one small reminder, the Fz force won't be the horizontal one, it's the local axis Fx, so the Fx force will be the horizontal one for loading. The next one is our PowerPack design. PowerPack design, we import the loads and combination into our PowerPack. You can see that the loads are there. Same for the combinations, and already the internal efforts for each load case for the given selected member. You can either calculate or put a constructive disposition that will show us the minimal reinforcement, and then we can edit, or we can calculate straight with the checks of the rebar. You can show the rebar and edit it, and then in case we need it, recalculate. Just show you the result here of the rebar of the column based on the results from Advanced Design. The same, just in PowerPack detailing, bottom rebar, either we can edit in Revit 3D view, or we can edit it directly in our special window. In this case, the results for theoretical reinforcement or rebar are imported from Advanced Design. You can see the moments, compared to moments, or the area of the rebar in Advanced Design. They are the same. Of course, we can display the bottom reinforcement in the other direction. You can display then with isolines and X-laces and several different types of display. But that's not all. You can, in the same window, define the rebar in the given direction. So it's bottom rebar in this case in the X direction. Just select the area, set the offset of the first rebar. We set, for example, 50 millimeters. And then we can play with the spacing and the diameter of the rebar. You can see by changing that the colors change, and you can easily detect whether it's the rebar is satisfactory for given area. You can see, for example, for distance spacing 312, diameter is not satisfactory, but diameter 14 is okay. Now you can see the results for real reinforcement that's already put in the slab. You can of course define other areas, and top and bottom, and then finish and generate a rebar. Just isolate the slab, and you can see the rebar using again our PowerPack detailing possibilities. In this case, rebar visibility. You can use rebar around openings, or just use edge reinforcement, and several different functions that will be probably shown to you tomorrow during the presentation. Here we choose the U-bar at the edge, the length of the U-bar, and we can add some edge bars, and just generate a rebar. Once the rebar is defined by using our PowerPack detailing or PowerPack design, it behaves as a standard rebar in Revit. The length of rebar, the setting of the diameter, spacing, the way of spacing, if you use just number with spacing or just single bar. So we use the results of the advanced design for direct definition of the rebar. Of course, you can play with the views and set the drawings, but the point of this presentation was showing you how to get the results from advanced design, from Revit to advanced design, and then back to Revit and use them. So that will be all from me today. Of course, if you have some questions, I would like to answer them if possible in that short time we have right now. In case I won't have time to answer them, here is my email address and my LinkedIn account. You can always join and check our web pages as well for more information about advanced design. You can also download the trial version at crytek.com free trial. And if it's not enough, you can always contact our local representatives. So I'll just check if there is any questions. the elements used in for meshing. We used Delaney meshing in advanced design, and I used the basic triangle and quadrangle elements for meshing. You can choose several methods and use D6 and S9 elements for meshing as well. The next question, if it's solid or shell elements, these are for the slabs are shell elements used. Okay. So as I said, if you would have any other questions concerning this topic, the BIM workflow used in advanced design and Revit, please contact me or our local representative, or just go to our web pages. I'm also available on my email address. And before I conclude my webinar today, I would like to invite you to following 2 webinars that will run tomorrow at 2 o'clock and Friday at 2 o'clock. Tomorrow with Stevens, and he will show you how to effectively apply the BIM workflow for your rebar projects using our modules for reinforced concrete in advanced design. And on Friday, Joseph will show you the general BIM workflow, how it is used in advanced design. So thank you very much for joining me today, and have a nice day.